Hi, and welcome back to the 14th video in our Python 3.6 tutorial series. In this video, we're going to be discussing Lambda expressions. These aren't really anything that I've personally found useful when I've been programming, but I know plenty of people use them, so I figured I'd cover them. First thing, I'm going to actually just mention that I said we were going to cover arbitrary argument lists and unpacking argument lists, but then after looking them, I realized I kind of already covered them. It's just what we covered in the previous video where you use the asterisk args and you can pass in as many arguments as you want. And then you can also do the double asterisks or single asterisks in the input of the function to input a list or a dict or something like that. So anyway, back to Lambda expressions. On these, I just want to first off show how to make a normal function again, just to make the comparison. So I'm going to do something simple like print x plus n plus 7. And then if we run this, we can enter in any number and then it'll add 7 to it. So we can do make incrementer 7, and then we run that and we see, oh, it printed 14. So then I'm going to compare that to the Lambda function so you can just see that on its own. So I'm going to name this make Lambda equals Lambda, going to say x plus 7 make Lambda 7, print it. And so basically what this is doing is it's using the Lambda function, which is an anonymous function, is what most people call it, where basically you're defining your arguments there like you would normally. So you're doing x instead of n. You can use whatever you want. And then here's your function after it. So it's exactly like we did up here where you're just doing x plus whatever. And so that's not particularly useful on its own, and I'll show how it's useful after. But we're defining this anonymous function right here to make Lambda, and then make Lambda becomes a function that we can explicitly call and pass through a 7. So if we run this, it's going to do exactly the same thing that we did on the previous function using the explicit define, make incrementer, all of that. So some people like this because it just saves them a line, but really if you're just adding two numbers together, you don't need all of this. So now I'm going to show what they show on the example one for calling these functions, or for Lambda expressions rather. So basically what this line is doing is we're returning a Lambda function with n entered in. Hang on, I have these mixed up. I'm going to switch these to x and n so I can match what they're doing. So basically, if you look at this, what this is doing is we're calling the function and we're passing in 42. So 42 is going into the function, and that's getting assigned to the n right there. And what this return Lambda does is it returns an anonymous function with x plus n as the function, and n being defined as 42. So then we're getting this function that says x plus 42. So we're assigning it to f, that anonymous function. So we can call f, and then what's happening is the n is assigned to 42, and the x is passed in to the f function. Hang on, I need a print. So then we see 42. And then we can try 1 just to show it's actually adding anything. 43. So that's basically all there is to Lambda functions. Just to explain really a little bit more explicitly, if we print this f, it's going to show that this is actually this Lambda function. So we've created a function within a function, so we can pass in different values here. So we could pass in 45 and it would change what f becomes. And then if I print f, we can show it became a function, a Lambda function, because of what was returned within that other one. And that's going to be it for our 14th tutorial on Lambda functions. I personally haven't had a great use for Lambda functions, but if you have one that you want to share, I would be gladly willing to learn about it, because I haven't seen it necessary really anywhere, but it is definitely a shortcut at times.